let's continue. And since someone just coming, and I will start from start. My topic is about the mechanism of the PDO in CESM large ensemble and the CMIP models. And I followed the Newman's 2016 papers work, and our goal is to understand the dominant mechanism of the PDO in CMIP class-like models and examine if these mechanisms are changing in the future climate. And our approach is to use a limb inverse model to compute the normal modes of Pacific climate following the approach of Newman's 2016 work. First, we break down the PDO into the three modes as Newman did. The PDO decomposition came up three dominant modes which can explain the PDO. They are the North Pacific mode, Central Pacific teleconnection mode, and the ENSO mode. By combining these three modes, we can reconstruct PDO, and this is PDO reconstruction, and this is PDO in the observation. The correlation coefficient for this is 0.68. And the question we want to address is how does the CESM large ensemble reproduce the PDO of these three modes? To do this, we explore the CESM large ensemble and compare to this observation here. We calculate 30 members, and for each ensemble member, we compute the normal modes from the limb and identify through clustering the equivalent North Pacific mode, Central Pacific teleconnection mode, and ENSO mode. And then we take the ensemble mean of these three modes. This is the observation, and this is for the CSM large ensemble mean. And overall, you can see CSM can capture the same model constituent of the PDO as found in the observation.
Shane, can I just ask a really quick question?
Yeah.
The ENSO mode is at least in the observational system, is actually a propagating mode, so there should be a cosine and sine phase.
Yeah.
You just didn't plot it here, but I mean you did get that, I would assume.
This is just the sine phase, or we usually call the most energy phase. We calculate because there's an oscillation mode, so one phase have a larger standard deviation, and we just pick them up.
Right, that's fine. I just wanted to check. Yeah.
Yes. Yeah. This is the most energy phase. Yep. And we found that both in observations and models, North Pacific mode have strong projection in QE region with a basin scale footprint, and Central Pacific teleconnection mode capture a Central Pacific warming and teleconnection to the X-tropics. And ENSO modes capture a more tropical confined ENSO structure. And then the question, what is scale in reconstructing the PDO from these three modes in the model? And we using this approach, and we got this individual models, and then this blue bar is for individual models for the correlation coefficient for the PDO reconstruction and the PDO index, and we calculate the ensemble mean, and you can see which is comparable to the observations. And
sorry, do your A, B, and C coefficients change for each CESM ensemble member?
Yes.
Yeah, actually, yeah. Yeah, because we use for each members we calculate different mode, so it changes in different members.
So the NP is like the normalized structure. Is that what you're saying? And the A is a time varying coefficient?
No. So for each model, right, the PDO index is reconstructed with the time series of the equivalent North Pacific mode, Central Pacific teleconnection mode, and ENSO mode, and each of these modes have different weights. So A, B, and C are the weights in the reconstruction. Okay, so if you add them together, they're one. And in fact, I think the next set of slides is about how each model is go ahead.
Yeah. Next is what is the relative contribution to the PDO of these three modes, and actually this different kind of bar is for the ABC, and it's the same with the correlation, and you can see here this is for observation, and observation for the matrix for each mode, and this is observation, and this is ensemble mean, and this is for the individual models, we found that ENSO mode is more dominant in the models compared to the observation, and the Central Pacific teleconnection mode is not as strong as the observation. This may show that in models there's a less teleconnection between the tropic and the extropic, and the North Pacific mode is comparable to the observation. However, there's a large spread in PDO composition across ensemble members. Yeah. For example, in this world, this looks a little bit like a real world, but in this world, it's completely ENSO dominant, while in these members, it's definitely the North Pacific mode dominant. So the relative importance of the PDO mechanism have strong internal variability within the same world. That means one realization of the observations cannot provide a single metric for evaluating the PDO process in models. And then we want to know, does human effects change the PDO processes, especially under the 8.5 scenario? We calculate this is for the three modes for the observations and for the historical ensemble mean. And we also calculate the RCP 8.5 ensemble mean. From this pattern, these three patterns are similar, except the change of North Pacific mode. The spatial footprint of the North Pacific mode appears larger in North Pacific. And we want to know what the scale would change in reconstructing the PDO under the RCP 8.5. I will remind you, this is our approach to reconstruct PDO, and this is a comparison for between RCP 8.5 and the historical run. If you look at ensemble mean here, they have similar scale, and if you compare the correlation in the individual models, they are comparable. So the correlation is not changed too much under the global warming. And what is the relative contribution of these three modes under global warming scenario? And this is same to the correlation, and this is for the observation and the historical ensemble mean, and this is for RCP 8.5 ensemble mean. And overall, we found that the ENSO become more and more dominant, while Central Pacific teleconnection mode become less and less dominant, indicating weaker teleconnection between tropic and extropical in the future scenario.
Of course, just as an interjection, this is just an analysis for the CSM large ensemble, right? This is not a general result. Other models may do it differently, right? But this is just a proof of case of using this approach, and why we would need a large ensemble to actually see some differences.
Yeah, it's almost done. So it's a quick summary for our work. First, we decomposed the PDO in the observations, and we got 3 dominant modes. The North Pacific mode has strong projection in QE region, and the Central Pacific teleconnection mode keeps Central Pacific warming and the teleconnection to the extropics. And the ENSO mode kept a more tropical confined ENSO structure. And we calculate the CESM large ensemble members, and we found they can capture the same module constituent of the PDO as found in the observation. And then we calculate the historical raw ensemble mean, and we compare them to the observations. We got the North Pacific mode in the models is comparable to the observation, and the Central Pacific teleconnection is not as strong as the observations, and the ENSO mode is more dominant. However, there's a large spread across the ensemble members. And finally, we calculate the RCP 8.5 ensemble mean, and we found that the spatial footprint of the North Pacific mode appears larger in North Pacific, and the Central Pacific teleconnection mode is less dominant, and the ENSO mode become more dominant, and there's still larger spread in across ensemble members. We want to mention that we also calculate the 24 CMIP models, and we found that few model can capture the processes of the PDO as in observations, and other unobserved modes become more important, indicating also a large model variability in the in processes. And the models that capture the PDO processes in CMIP cannot provide a robust estimate of the future change in PDO because of the internal variability. We need more large ensemble. So this is all my points. Thank you.
I just wanted to make one comment about the statement that the PDO processes, that the models cannot capture, the CMIP models cannot provide robust estimate of future changes in PDO. I think what we mean here is that Sheng has done the same type of analysis on an ensemble of different CMIP models, but we only have, in this case, one realization of each of the CMIP models. And so with one realization of each of the CMIP models, these models can do the PDO, they're different worlds, right? So you could actually be sampling one realization where the PDO world is dominated by ENSO versus one that is dominated by North Pacific. And so it's hard with one realization of each CMIP model to really, say anything kind of reasonable about the changes in the PDO. Ideally for each of the models, you have a large ensemble so you can decompose what's really the internal variability versus the differences in model biases. Does that make sense, guys?
Yeah, I'm a little nervous with the CPEP in these models because I'm not convinced that they capture them in the way the real world is, because everything's shifted too far to the west, but you run out of real estate.
Are you concerned about
not like the ocean just kind of goes on forever? You still have the maritime current. I mean, this is just classic, but you see this in all these models. And I think that's a part of it. So what's happening is the ENSO mode here is in reality looks a little bit more like the CP mode in observations, except not entirely. And then the CP mode in the model doesn't really look like observations either. And I think this is a large part of this issue.
Well, that's in a way like that's what we're trying to target with the DOE project as a whole, right? Like trying to understand what is it about these model modes, and is there some aspect of their bias relative to observations that's associated with systematic changes in the PDO? So, I think it's okay.
Oh yeah, no, it's fine. I just want to be clear that I think this is fine. I'm saying I think the root cause of the models not capturing this correctly, though, is this shift. All the models shift to the west. They all shift ENSO to the west, and that screws up the teleconnections. And it's the teleconnections which drive in the extratropical response to the tropics.
Anyway,